Hello everyone, and welcome to my channel. In this video, I will present you my group research project called Unsupervised Anomaly Detection in Water Distribution System using Autoencoder and Isolation Forest. Now, before we get into the presentation, there's an overview I want to discuss. First, we have the introduction. Second, we have the literature review. 3, we have the research question and hypothesis. 4 is the methodology. And 5 is the expected outcomes. And 6 is the timeline and resources. And finally, 7, the conclusion. Alright, let's begin with the introduction. Modern water distribution systems rely heavily on IoT sensors and SCADA networks. While this improves automation, it also increases exposure to cyber attacks, operational faults, sensor failures, and also major... Alright, let's begin with the introduction. Let's begin with the introduction. Modern water distribution systems rely heavily on IoT sensors and SCADA networks. While this improves automation, it also increases exposure to cyber attacks, operational faults, and sensor failures. A major issue in this domain is the lack of labeled attack data. Real attacks are rare and difficult to annotate. This makes supervised learning impractical. Traditional threshold based on monitoring is also no longer sufficient. Water system data is multivariate, nonlinear, and also dynamic, so simple rules often miss subtle anomalies. Because of these changes, unsupervised learning has become a promising approach. Methods like Autoencoder and Isolation Forest detect anomalies by learning normal behavioral patterns rather than relying on labeled attacks. In our study, we directly compare these two models under the same condition using the BATADAL dataset. Now, let's move on to literature review. Literature shows that IoT integration increases WDS vulnerability to cyber physical anomalies, especially subtle shifts in flow and pressure. A key theme is lack of labeled data, which pushes research towards unsupervised methods. Autoencoders are effective at learning complex nonlinear dependencies and detecting anomalies through reconstruction error. LSTM-based autoencoders perform especially well for temporal sensor data. Isolation Forest is known for being efficient, scalable, and suitable for high-dimensional datasets, performing best when low latency and minimal computational overhead are needed. Despite extensive research, there are very few systematic head-to-head comparison between autoencoders and Isolation Forest under identical settings, particularly on BATADAL. This forms our research gap. Now, let's look at our research question and hypothesis. Our work addresses these three questions. First, how can unsupervised model detect anomalies without labeled data? Second, which model, Autoencoder or Isolation Forest, performs better on BATADAL? And finally, third, what accuracy efficiency trade-off exists between these two methods? Now we have a test that first, Autoencoder will outperform Isolation Forest in detection accuracy. And second, Isolation Forest will require less computation and provide faster interference. And lastly, a unified experimental setup will reveal clear performance trade-offs. Now let's continue with our methodology. Here we have the framework. Next we have data collection. We use BATADAL datasets which contains normal operation data and test data with cyber attacks. It covers over 40 numerical hydraulic variables such as flow rates, pressure, tank level, pumps, and valves. And next is methodology processing. Here, we remove non-numerical and constant feature handled missing values using forward fill and backward fill, and standardize all numerical variables to ensure consistent model input. Next, here is a data partitioning. Here, we split the dataset into a 90% train, a normal train-only training set, a 10% validation, a validation set that threshold selection, and a test set that includes attack intervals. We kept the temporal order to preserve real-world time series behavior. Next, we have the model development. In the autoencoder model, the autoencoder consists of an encoder, bottleneck, and decoder. It reconstructs normal data and flags anomalies with reconstruction error is high. It captures nonlinear sensors relationship but requires more training time and computation. And next is the Isolation Forest model. The isolation forest isolates anomalies through random feature splits. Anomalous points are isolated more quickly and produce shorter path lengths. It is extremely fast and lightweight, making it suitable for real-time environment, but it is less effective for subtle nonlinear anomalies. Next, we have the evaluation metrics. We evaluate performance using precision, recall, F1 score, based on the attack labels in the BATADAL test set. And next is the comparative analysis. Here are the key findings. First is the accuracy. The autoencoder achieved higher precision, recall, and F1 score. And second, in terms of robustness, autoencoder handles correlated and noisy data more consistently, while isolation forest performs less reliably in this condition. And the next is the efficiency. Isolation forest is significantly faster and requires fewer computational resources. Meanwhile, autoencoder is slower but provides stronger detection performance. Overall, autoencoder is for better accuracy, and isolation forest is for better real-time efficiency. Now, let's move to the expected outcomes. And here, we expected that the autoencoder is expected to achieve stronger anomaly detection accuracy due to its ability to capture nonlinear hydraulic relationship. Isolation forest, however, should deliver faster interference and minimal resources usage, making it suitable for a real-time or edge deployment. It's also expected that this study will help highlight the practical trade-offs between accuracy and efficiency, helping the system engineers choose the right model. Now, the result will support better cybersecurity monitoring strategies for water distribution and other industrial control systems. Here we have the timeline from our group project. And lastly, the conclusion. Unsupervised anomaly detection is crucial for water distribution system where attack labels are scarce. Autoencoder generally provides higher accuracy by modeling complex sensor interaction. Isolation forest remains attractive for real-time application due to speed and simplicity. These research provide a unified, fair comparison on BATADAL, addressing a major gap in current literature. Findings can guide practitioners, engineers, and researchers in selecting appropriate model for critical infrastructure security. And that's all from my presentation. Thank you for listening. Bye-bye.